MBA633 instructional video prepared by Professor Amit Tata, School of Management, George Mason University. In this segment, we will focus on the built-in functions that Excel provides to do probability calculations for the normal distribution. We will not be doing any problem solving per se in this segment. Just we'll see how to master the built-in functions. Once we have that under our belt, the next instructional clip that I develop, in that we will do actual problem solving with the normal distribution, and then we will assume that the built-in function exercise has been understood. So consider a general normal distribution that's given to you over here. So it's a normal distribution with a mean of 10 and a standard deviation of 3. Okay, so how do you do probability calculations? And just for our reference, to help us with the discussion, just notice these two letters that I provide, the letter A and the letter P. A is simply a position on the x-axis, okay, and P is the area under the normal distribution to the left of A. Okay, the shaded yellow portion, its area is represented by P. So based on what you know about the normal distribution, small p is equal to the probability of x, the random variable x, which has a normal distribution, being less than a. So p is the probability of x being less than a. Now, there are 4 built-in functions that Excel provides to deal with the normal distribution, and you can categorize them in a systematic way, so to help us remember what they are. One set of built-in functions ends in the word dist, so you can see norm dist, norm s dist. The other pair ends in inv, inverse, norm inverse, norm s inverse. Okay, so you take any one set, let's say norm dist and norm s dist. The difference is the letter s. The letter s signifies the standard normal distribution. So if you remember, a standard normal distribution is the special case of a normal distribution which has a mean of 0 and a standard deviation of 1. So I will show you simply how to use norm dist and norm inverse, and whatever I say for those two apply equally well to norm s dist and norm s inverse, the only difference being you would use the latter two when you're dealing with a standard normal distribution. Okay, so let's look at a few problems here. Let's say the first problem I want to solve is probability of x less than or equal to 7. As you can see, what I've noted in the comments over here, you use either one of the dist built-in functions, that is norm dist or norm s dist, when you know A and you want to find P. In other words, you know your position on the x-axis and you want to know the area under the normal distribution to the left of that point. So you want to find a probability. So if you know A and want to find P, you will use one of these two dist functions. The converse is, if you know P and you want to compute where on the x-axis do I have to be in order for the area under the curve to the left to be P, then I will use the inverse function. So if I know P and I want to find A, I will use one of the inverse functions. If I know A and I want to find P, I will use one of the dist functions. I will use norm dist or norm s dist. Okay, so let's try the first one. What is the probability of x less than or equal to 7? You can see that this normal distribution has a mean of 10 and a standard deviation of 3. So it is not the standard normal distribution, it's a regular normal distribution. So since I know where I am on the x-axis and I want to find P, I will use norm dist. And you can see that it requires 4 inputs. The first input is, where are you on the x-axis? So that's 7. I want the probability of x less than or equal to 7. Then what is the mean of this normal distribution? It's 10. What's the standard deviation? It's 3. And this last parameter, since we are looking for an area to the left of A, in other words, it's a cumulative probability. I'm not looking for the height of any one spike. This value will be 1. You remember what we did for the binomial and Poisson distribution. So for continuous distributions, particularly for the normal distribution, I'm willing to bet that 99.9% of the problems that you solve, you will use 1 for this last parameter, cumulative. Okay. The main thing to remember is that the Excel built-in function normdist always gives you the area to the left of the point where you are on the x-axis. So it will always give you the shaded portion to the left. Okay. Now, if you don't want that the area to the left, you'll have to do some geometry. Okay, so we'll see that. So the answer is 15%. So the probability of x being less than or equal to 7 is 0.158 or 0.16. Now, what is the probability of x being greater than 11? So here is 11. So obviously the probability of x being greater than or equal to 11 is the area to the right of 11. The area under the normal distribution to the right of 11. Unfortunately, the built-in function does not give that number to you directly. Okay, so let's first do equal to norm dist 11, the mean is 10, the standard deviation is 3, and cumulative is 1, and we get a number. Okay, it's 0.63. But this 0.63 is the area to the left of 11. Okay, always remember that Excel, the built-in function norm dist, norm s dist, always gives you the area to the left of a point on the x-axis. Okay, it never gives you the area to the right. This is for the norm built-in function. So since I want the area to the right of 11, you know how to solve that problem. Since the area under the curve must be 1, that's the cumulative, the sample space is the area under the curve, rather the probability of all outcome is the area under the curve. So the probability of x being greater than or equal to 11 is simply 1 minus 0.63, which is 0.37. Okay. All right. Now that you know this fact, I think it's very easy to compute this last probability. What is the probability of x of 7 less than or equal to x less than or equal to 12? It's the shaded portion between 7 and 12. So if I have, let's say, x equal to 7 over here and x equal to 12, so it would, I don't want to clutter up the diagram, but if this is 7 and this is 12, you would simply have the area under the bell-shaped curve between those 2 points, 7 and 12. And Excel does not give that to you directly, but I think by now you can guess how one would do that. You just do some geometry, you subtract areas. So we'll say equal to norm dist 12, 10, 3, 1. This is the area to the left of x equal to 12. And now let's do norm dist 7, 10, 3, 1. So this is the area to the left of 7. All right. So if I subtract one from the other, the first minus the second, this is the area between 7 and 12. So the probability of x being between 7 and 12 is 0.588. Okay. Now let's turn our attention to the second type of calculation that we might want to do. So find an A such that the probability of x less than or equal to A is equal to 0.35. So I'm being told that I want to find a position on the x-axis A such that the area to the left of A is 0.35. When you know the probability and you want to find the location on the x-axis, you use the inverse function. So we will do equal to norm inverse, and it wants some numbers. So what probability, what is the area to the left that I'm being told? That's 0.35. The mean is 10. The standard deviation is 3. So once I give these 3 inputs, it comes back with the value 8.8. So basically it says that the probability of x being less than or equal to 8.8 is 0.35. So you would have to be at the location on the x-axis would be 8.8. This is the location where you have to be. Okay, and that makes sense because the mean is 10, so obviously you would have to be to the left of 10. Since the normal distribution is a bell-shaped curve, the area to the left of 10 is 50%, the area to the right of 10 is 50%. If I'm looking for an area to the left of 0.35, obviously I have to be somewhere below, less than 10, and the calculation, the built-in function tells me I have to be at 8.8. Now, what if I'm told find a location on the x-axis such that the area to the right of that point is 0.35? So I want an A such the area to the right is 0.35. Now, Excel does not work with right side areas for the norm dist and norm inverse function, but there's a very easy way around that. If the area to the right of A is 0.35, the area to the left must be 0.65 because the area under the total bell curve is 1. So how do I find the location of of A? Obviously it has to be something higher than 10 because the mean is 10. So let's see what it would turn out to be. So we would say norm inverse, and the probability, I do not put 0.35 now, I put 0.65, and I hope you see why, because that's just the way Excel, the stamp norm that Excel uses. It wants the left hand side area. Okay, so I have to give it 0.65 as the input rather than 0.35 in order to find the correct location on the x-axis. So the probability is 0.65, the mean is 10, and the standard deviation is 3. I should get an answer that's somewhat higher than 10, and it turns out to be 11.1. So I have to be at 11.1. So in other words, the probability of x being greater than or equal to 11.1 is equal to 0.35. So I hope you see how to use these 4 built-in functions. Everything that I just told you about norm dist and norm inverse would work exactly the same way for norm s dist and norm s inverse, provided the normal distribution that you have is a standard normal distribution. In other words, it would have the mean of 0 and a standard deviation of 1. So keep in mind, the trick you have to keep in mind is that for the norm dist and norm inverse function, the probabilities or the area under the curve that Excel gives you or wants is the area to the left of a point on the x-axis. Once you keep that rule in mind, that's the rule that Excel uses, everything else should be easy to do. You can use the area to the left, or if you need to, you will do 1 minus the area, depending on what probability you want to compute. So this is how Excel works, and in the next video clip we will actually work some probability problems with the normal distribution and these built-in functions.